In this video, we're going to talk about triangles, their sides and their angles, and how if you know one of those two things, if you know side lengths, you can figure out the least to greatest order of your angles, or if you know your angles, you can figure out the least to greatest order of your side lengths. We're going to start with knowing our angle measurements, but not knowing the side lengths. So here is an acute scalene triangle where I gave you all three angle measurements. All three of them, when you add them up, equal 180 degrees. But I am being asked, hey, Miss Douglas, can you list the side lengths in order from least to greatest? I don't actually know. I don't have a ruler with me. I don't know how long they are, but that is not going to stop me. Since I know the angle measurements, I can figure it out. Here's how. If I'm looking for the smallest side length, I'm going to look for the smallest thing that I do have information on, the smallest angle. Between 59, 47, and 74, 47 is my smallest angle. It is made up of this side length and this side length right here. This is AC, this is AB. This 47 degrees is angle A. Now, I angle angle A to make side length AC and to make side length AB. Together, they create the space for this side length right here, CB. That is directly opposite from angle A. This is going to be my shortest side length. So my shortest side length, my least, would be CB or BC, doesn't matter. That is because it is across from the smallest angle in my triangle. Now, next up, I'm looking for my middle side. To do that, I'm going to look for the mid-sized angle. 47 was the smallest, 59, 74. 59 is my mid-sized angle. It's made up of these two side lengths right here, AC and CB. This is angle C, and I know that because the two side lengths that create it each have a C in it. Now, angle C is made up of these two blue sides. If it were a bigger angle, let's say 90-degree angle, the sides would increase in this angle shape. If it's a 90-degree angle, it's actually going to make a little rectangle, a little square. If they were to decrease and become more acute, they might look like that. Still angle C, but you notice that in a small, acute little angle, I don't actually have that much space that needs to be filled. In a bigger right angle, suddenly my side length has to be a lot longer. So when we are looking at an angle, the side length that does not help create the angle, the one directly opposite from it, that is the one that this 59-degree angle is helping to create. So this is the medium angle. That means that side AB is going to be the medium size, which means that our largest angle, angle B, this 74-degree angle, which is created from the side length AB and side length BC or CB meeting, the 74-degree angle, across from it is side length AC. That's going to be the biggest side length. Now, sometimes my pictures can be confusing. Sometimes you can't quite tell. You won't always have access to a ruler. So this is the way you can prove it with math. Even if these two side lengths maybe look really similar and you're like, from the picture you can't really tell. If you can prove it with math based on your angles, then you know you got it right. Let's try another one. Here we go. This is called a 30, 60, 90 triangle because it's a very common angle measurement. 30 plus 60 plus 90 adds up to 180, so I'm good. This is a real triangle. I'm going to try and list my side lengths from greatest to least. If I'm looking for the greatest side length, that means I'm looking for my biggest angle. This symbol right here means it's a 90-degree angle. 90 is the biggest out of 30, 90, and 60. It's being created by this side length and this side length. So those are not the sides that are the length is not dependent on this angle. 90 degrees across from 90 degrees, this side length, YZ, does depend on this 90-degree angle for its size. It is the largest size. YZ is my biggest side length. Now I'm going to look for my medium one. Between 30 and 60. 60 is the next largest, the middle size. It's being created by XZ and YZ, which means that the one side length that is dependent upon the 60-degree angle is the one between X and Y. XY is the middle side length. Last but not least, my smallest little acute angle right there, 30. Across from 30 is this side length here, XZ. XZ is made up of, angle Y is made up of two side lengths, XY and YZ. They create this 30-degree angle, and the side length XZ is determined by the size of this 30-degree angle. So this is my greatest to least order here. This is an isosceles triangle. I only know one of my angle measurements here. This is like a double kind of question. You have to figure out what angle P and angle R, what those angle measurements are before you can start listing the side lengths. But here's something that I do know. This line and this line right here mean that PQ is the same exact size as QR. If this is one side length, then I know that the angle opposite depends on this side length. But if it is the exact same measurement as this one over here, then I know the angle opposite of it is going to be the same size. These are called congruent or complementary angles. Angle P is going to be the exact same size as angle R. How do we figure that out? Okay, I know that angle R plus angle P plus angle Q will equal 180 degrees. So if I subtract away the 23 degrees I know that I have, that gives me 157. I need these 157 degrees to be equally split between angle P and angle R. To equally split them, I'm going to divide them by 2. 157 divided by 2. 2 goes into 1 0 times. 2 goes into 15 7 times with a remainder of 1. 2 goes into 17 8 times with a remainder of 1. 78, put a decimal, raise that decimal to the roof, add a 0, drop it down. 2 goes into 10 5 times. Angle P is 78 5/10 degrees, and angle R is also 78 5/10 degrees. Now, if I'm going to use those measurements to decide which one is my shortest to longest, side lengths. Well, I've got 78 and a half, 78 and a half, and 23. 23 degrees is my smallest angle. The side length directly across from that is PR. PR is my shortest side length. I already know that these two sides are equal. So it's kind of a tie between PQ and QR. These are going to be the exact same length, but they're both longer than side PR. Sometimes you're given side lengths, but not the angles. If my question asks me to list the angles from least to greatest, I just do it the opposite way. In the last few problems, I was looking at the angles and using that to make assumptions about the side lengths. Now I'm going to look at the side lengths. If I want the least angle, it's going to be across from the smallest side length. Well, 18, 19, 20, 18 is the smallest side. Across from 18 is angle R. No, that's not an R, that's a K. Angle K is going to be my smallest angle. 19 is the next smallest, it's the medium one. Across from 19 is angle J, which means that the biggest angle here is across from the biggest side length. Angle L is the largest, or the greatest size. I don't ever need to know exactly what size they are. I don't need to get out a protractor to measure them, to check, because this is the mathematical proof that I need. My opposite sides and opposite angles